Okay, the final portion of section 1-1 in your trigonometry book discusses the idea of coterminal angles. Coterminal angles are defined as being two or more angles which, when graphed in standard position, which we discussed in an earlier video, earlier in this set of notes, have identical pictures except for the label. In other words, their terminal sides are in exactly the same place. So for example, let's look at 70 degrees and 430 degrees. Well, in either case, we're still going to start with our vertex at the origin and our initial side on the positive x-axis. Yes? Computer's being a little... So we start off with both of those angles. We'll start with one side on the positive x-axis. Remember that is 0 degrees or 360. Okay, remember that the positive y-axis, that is 90 degrees. That the negative x-axis is 180 degrees. And that the negative y-axis is 270 degrees. It's 90-degree increments. So, when we finish drawing 70 degrees, that would be somewhere in the first quadrant with a label of a rotation of 70 degrees. Now, interestingly, 430 degrees, well, we need to keep in mind that 430 degrees is more than one full rotation. One full rotation is 360 degrees, and then we would have, oh look at that, another 70 degrees to rotate. So the only difference between our 70-degree picture and our 430-degree picture would be that we would have a label that showed a full rotation, and it would end at exactly the same place. So 430 degrees would be the exact same picture. So notice that coterminal angles occur at 360-degree increments. So, just because we can, what would one more angle be? Well, let's go negative. Let's say that we took, instead of rotating in a positive direction, we rotated in a negative direction. Well, that angle that would have the same picture would be 70 minus 360, or negative 290. And again, we can show that just with another arrow rotating in the opposite direction and labeled with negative 290 degrees. All three of these angles, 70, 430, and negative 290, have the same picture when drawn in standard position. The only difference will be the label. Okay, so what do we have to do with that information? Well, you're going to see problems that say, find the angles of least positive measure, which would be in the first rotation, between 0 degrees and 360 degrees, that are coterminal with each angle. So 908 degrees. We have to ask ourselves, is that between 0 and 360? The answer is clearly no. So what we do is we subtract 360 degrees. We subtract one rotation. That gets us down to 548 degrees. Is that between 0 and 360? No, it is not. So we just do it again. Subtract another 360 degrees. And that gives us 188 degrees, which is the angle of least positive measure that is coterminal with 908 degrees. Okay. So our second example here is negative 75 degrees. Is that between 0 and 360? No, it is not. However, it is actually less than 0. So instead of subtracting 360, we are going to add 360, which would be 285 degrees. And we ask ourselves, is that between 0 and 360? If the answer is yes, then that's the answer to the question. So on number 3, we would do the same sort of thing, except we'd have to add a single rotation a couple of times. In fact, 3 times would get us there. If we add 360, 360, and 360, we get an answer of 280 degrees. So that's the first problem where we're going to have to deal with coterminal angles. Okay, next up, a little bit wordier problems. Draw each angle in standard position. State 2 coterminal angles to the angle, one positive and one negative, and state the quadrant where the angle terminates if applicable. Now, why would it say if applicable? Well, if it ends right on an axis, then it doesn't terminate in a quadrant. So if it's coterminal to a 90-degree angle or a 180-degree angle or a 270 or a 360, then it would not have a quadrant. So essentially, this question is putting the entire section together, more or less. So here's how I suggest that we do this. First of all, you ask ourselves, okay, I know that when I draw this in standard position, that one side of my angle is going to be on the positive x-axis. So always start there. Draw your initial side and your vertex. Then ask yourself, okay, knowing that this is 0, 360 degrees, that this is 90, that this is 180, that this is 270, what quadrant do I end in? Well, if it's 138 degrees, that's between 90 and 180. So I draw my terminal side in quadrant 2. And by the way, I have to state that somewhere, so we might as well do that now. That terminates in quadrant 2. We need a label showing that it's a 138-degree angle. That takes care of drawing it standard position and stating the quadrant. Now we just need the coterminal angles. So to get a positive coterminal angle, we're going to take the 138 and add one rotation, which would be 498 degrees. So there's the positive coterminal angle. And to get the negative coterminal angle, we're going to take the original angle 138 and subtract 360 degrees, which would be negative 222 degrees. So again, this problem has 4 answers. We need to draw the angle in standard position, which is this picture here, labeled. State 2 coterminal angles, one of which is positive and one of which is negative. And state the quadrant where the angle terminates. So 310 degrees. Again, we know that it's going to start with one side on the positive x-axis. 310 degrees is going to be between the 270 and 360 marks. So we label it with a 310-degree rotation. That is ending in quadrant 4. So that takes care of the picture and the quadrant. For the positive coterminal angle, we're going to take the angle 310 and add 360, which would be 670 degrees. Now keep in mind that if your original angle is more than one full rotation to start with, then you're going to have to adapt to that. You can still add 360 to get a positive coterminal, but to get the negative, you're going to have to subtract more than once. Your answer has to be a positive angle that's coterminal with 310 degrees. Same thing for the negative. We're going to take 310 degrees, and we're going to subtract 360, which will give us negative 50 degrees. Hopefully these examples are helpful, and that completes section 1.